Okay, so I'm recording this one so you can go back and listen to it after we go over it today. So we're going over this because your test is when? Wednesday. So you have your test on Wednesday for chapter 5 and 6. So this is the study guide that you should be studying. We're going to go over the study guide. Study the study guide. Okay? So number 1, write the logarithmic equation in exponential form. It says log base 3 of 9 equals 2. What method am I going to use to rewrite this in exponential form? Circle method. So I am going to draw my circle starting where? 3. The base is 3. So we're going to start at the 3, draw it to the 2, and then to the arrow to the 9. So here's what I'm just drawing my exponential boxes. So what goes in the first box?
3.
Second box?
2.
Last box?
9.
That's it. Pick the answer. Which one is the right answer? A. Number 2, we're going to do the same thing. It says log base W of Q equals 19. Circle method, put my dot underneath the to the 19 and then the Q. Dot under the W, draw your arrow to the 19, then to the Q. Write it in exponential form. It's going to be what goes in the first box. Second box.
19.
Equals?
Q.
Done.
D.
Easy, right?
Yes.
Okay. Number 3. That one's written in what kind of form? It's written in logarithmic form, and it wants you to turn it back into what? Then when it says, excuse me, it's written in exponential form. I'm sorry, I said it backwards. It's written in exponential form, and it wants you to turn it back into a log. All right, are we gonna do the circle method? Of course we are. So I've got 6 to the 3 power equals 216. Where do I put my dot? Under the 6, which is called the base. So dot under the 6, draw your circle to the arrow to the 216, and then the last arrow to the 3. All right, log. Need a box here, and a box here. What goes in the first box?
6.
Second box.
16.
Last box. Which one says that? See, okay. Number 4, same method. I've got 10 to the 3rd power equals 1,000. So now I'm gonna do my circle method again. Put a dot under the 10, draw your arrow to the 1,000, and then your last arrow to the 3. All right, first box. Oh, I wrote it wrong, didn't I? Thank you. I'm supposed to be writing it in log form, not exponential form. It's already in exponential form. Already log. Thank you. All right, what goes in the first box? 10. Second box? 1,000. So I have to make sure that fits in there. Last box? Done. Okay. Number 5 says evaluate the logarithm if possible, and then round your answer to 4 decimal places. Literally, you type it in your calculator. Now, do you have, everybody should have that button on your calculator. So you just put it in your calculator, what you get. Somebody tell me what you get when you put that in your calculator. Log 2.81 equals what? That's what y'all got? Everybody should get the same thing. Just press the button. That's the easy one. Number 6 says graph this. Are you going to need a graphing tool? Yeah. So the question is, which one of these pictures does that look like?
So we're going to use Desmos for that one?
You would have to use Desmos unless you already know what that one looks like. Now, I know you know what it looks like, but Y'all like, so yes, you would go type this in Desmos. So I'm just looking at the curve. So I'm gonna go to Desmos from here. Y base, Y log base, say, let's see.
You put it in Desmos.
Is it
Oh,
just
yeah.
log? Is it just log?
Yeah. Yeah.
Because we didn't have line going through it, so.
Yeah. That's
All right. All right, that's the curve I got. So is that the curve that you got? Okay, let me raise this other stuff over here so you can see. So I literally just typed that in Desmos so I could see what my curve was gonna look like. All right, what questions do you have?
no question.
Pick the picture. Pick the graph that represents the graph that you see on the screen. All right, back to the study guide. What answer was that, D? Okay. All right, number 7 says, given log of 2 is equal to 0.3010 and log of 3 is equal to 0.4771, evaluate and find the log of 6. So it wants you to find the value of the log of 6. What numbers did they give you? 2 and 3. Always look at these numbers. The numbers you're paying attention to is this number and that number. So they gave you the log of 2 and the log of 3. But what do you know about 2 and 3? They multiply together and give you how much? 6. Okay, well that was easy. So log of 6 is equal to what? What should I write next? Log of 2 times 3. And that's multiplication, which turns into addition. So we're gonna have log of what? 2 plus log of 3 is equal to, and then I just use the numbers that they gave me. They told me the log of 2 is 0.3010, 0.3010, and log of 3 is 0.4771. I just add those two things together in my calculator, and I should get, let's see what that is, 8, 7. Y'all check my math. Does that look right? Did you get 0.7781?
Yes.
Okay, done.
1.3.
Now, given that this is on the board, could I have asked you for the log of 18? How would you do that problem given that's the log of 6? Can you tell me how to do this? This is something I'm adding to the test study guide.
3. Log.
Log what now?
6 times 3.
6 times 3? Can I use 6?
Yeah, if you know what it is.
Well, wait. Can you use 6 based upon the information that they gave you?
Oh, no.
No. You only have a 2 and a 3. Can you use 6?
Yeah?
Yes.
Yeah.
We figured out 6, but I'm assuming you ain't got that. You gotta assume you ain't got that up there already. We're starting with a brand new problem and you ain't got log of 6 up here on the board. What should I do? So tell me what to write then. 2 times 2 times 3. Is that equal to 18?
2 times 3.
Okay, 12. Change this to a. All right, we're good? Okay, so now that you know that, what do I now write? Log what?
2 plus 3 log 3 plus log 3.
Got you. You okay? All right, you understand what it could look, it could be a problem that is not gonna make it so easy for you. Again, I could say, tell me the log of, and I could pick another number and say 27. I could do 81.
Don't do it anymore.
You know, you see what I'm saying? I could do 162. You see where you still can only use 2 and 3, so find the numbers that divide by 2 and 3, and you'll figure out what to do with that. So this is just an addition to show you how it could change. Okay? All right. So We're good with number 7?
Yes.
All right, number 8, find the inverse of the function. Now this one's easy. So you've got f of x, oh, that's not right. You've got f of x is equal to 5 raised to the x power. Step 1, rewrite f of x as a y. Step 2, switch x and y around. Step 3, turn it into a log by filling in the boxes.
Log 5x equals 1.
So if I do my dot goes here. So log base 5. Log base 5 of what? Log base 5 of x equals y. Now, rewrite it, put it back in function form. It's the same, these two are the same thing. I'm just rewriting it in function form. So all you're looking for is the answer that says that. Which answer has that? See. Now, what you might see, you be like, wait a minute, this 5 don't look like it's supposed to, that 5 is supposed to be a smaller 5, but the way the computer prints it up on the screen, it won't make it smaller than that. But it should look like that. That's what it means. So don't think that 5 is sitting at the same level as the LOG. It's not. It's hanging low, even though it doesn't look like it's hanging low. Okay, questions?
Can you tell me how is an inverse?
Say it again.
What? How come it's an inverse? It looks like you're just turning it into like a log.
I am just turning it into a log. But when we first started talking about logarithms, one of the first statements we made is a log is an inverse of the exponential function. So they are inverses of each other.
Okay,
So-
please look at
So this is, the original is an exponential form. This is in log form. They are inverses. So when you take an exponent and turn it into a log, you just turned it into its inverse.
I forgot.
So yes, they are inverses. Alrighty, number 9. Number 9 says use the properties of logs to evaluate the expression. Okay, use the properties of logs. Do you remember what the properties of log says? Now look at what you see here. You got 6. What's the exponent here? Log base 6 of 2x. So one of your properties says when this and this are the same, what's the answer? 2x. Remember the property said if you have, and again, the way they wrote it, it was it had b raised to the log of b of, and it might have had a x here. And the answer was x. So if you have these two are the same, that's a b and that's a b. This is a base and that's a base. If they are the same, the answer is whatever this is. So if that's an x, your answer is x. If it's a 2x, you put 2x. If it's a 3x, you put 3x. If it's a 59, you put 59. Whatever this is the answer. So in this particular case, it's 2x. When these two are the same, the answer is whatever that is. That's the property. Number 10. Number 10 says use the change of base formula. Now I have one question for you. Do you have to use the change of base formula? Some of you do and some of you don't. Who has to use the change of base formula?
Depends on how our calculator is set up.
Correct. If you have the button, you don't have to do the change of base formula. You can just put that in your calculator just like it is. However, if you do not have the button, what's the change of base formula? You got to write it different in your calculator. Tell me what to write. Log of what?
16.58.
Uh-huh.
Divided by log 6.
Done. How do you know what number goes on top and what number goes on the bottom when you rewrite that?
The base is on the bottom.
The base is always on the bottom. Another way to remember it, the number that hangs down low goes low. Got it? That's how you have to put it in the calculator. If you don't have the button, some of you have a button on your calculator that lets you change the number that goes here. If you don't have it, you gotta type it like this. And then, of course, tell me what the answer. Somebody tell me what the answer is.
1.567.
A. Number 10 says solve the equation, and they want the exact answer, so that means they don't want you to round it. So here we go, solving number 11. Log base 5 of x equals -3. Whenever you're gonna solve an exponential equation or a log equation, you're gonna do the circle method. Can I do the circle method?
Yes.
Alrighty, box, and a box here. Alright, first box.
What is it?
Alright, what's the answer? Now, you notice it's not one of those answers up there, so they want you to put this in the calculator. What you get?
0, 0, 8.
Okay, when it says it wants the exact answer, it doesn't want you to tell me what it is, 0.0985. It doesn't want the decimal version, it wants the fraction version. So here's how you rewrite this. Whenever you have a negative exponent, the exponent causes the negative exponent to turn into a fraction. This whole part goes down bottom, but the negative goes away. When you rewrite it in fraction form, the negative sign goes away. It's always gonna be 1 over whatever the original expression looks like. So if it's 5 to the -4, it's gonna be 1 over 5 to the -4. In this case, 5 to the -3 is 1 over 5 to the 3 power. So now you just need to know what's 5 times 5 times 5. 125. So that's my final answer is 125. They do not want whatever it is in the calculator. Some of your calculators will put it in fraction form, and then you can change it to a decimal. But that is the final answer. It's 1 over 125. Number 12. Number 12 wants you to use the properties that says multiplication turns 2. Multiplication turns 2.
Addition.
Okay. Division turns 2.
Subtraction.
Okay. And exponents our exponents get pulled to the front. Okay. Alrighty. So here we go. Let's put this one up here. So I've got log base 2 of x raised to the 8th power, y raised to the 7th power, all of that divided by 5. Alrighty. Can I rewrite it so you can see it in times form? When I say rewrite it, can I rewrite it like this? It should be an 8. I'm rewriting it in this form. Can I rewrite it like that?
Where did 2 go? Or just this piece?
Oh, it just stays.
Oh.
You don't do anything with it, it stays right where it is. Now, do you have to do that step? No. But I wanted you to see it specifically so that you can see this is times, this is division. Now, what did our property say now? Multiplication turns to what?
Addition.
So now that's gonna be log base 2 of x to the 8th power. Then what do I put here? What symbol?
Plus.
Plus what?
Y7.
Log base 2 of y to the 7th power. Division turns to what?
Subtraction.
Subtraction. So what should I put? Subtract what?
5. Make log 2 of.
Am I done?
No, you put exponents.
Can't leave exponents in your answer. Why can I not leave exponents in my answer? Because they gave you a property to do something with it. So you can't leave your answer like that at all. You cannot leave the final answer with exponents in it because we said what happens to exponents when they're in log form? They get pulled to the front. So tell me what I should write here for this first part.
8 log of 2x.
8 log base 2 of x plus what?
7 log 2y.
We have 7 log base 2 of y minus log base 2 of 5. Now you're done. Cannot leave exponents in your answer. We just followed our property. Remember, multiplication turns to addition, division turns to subtraction, exponents get pulled to the front. We did all of that in that problem.
If the 7 log 2y was a 7 log 2x, would we combine like terms?
No. In their cases, Robin, you may have to. In this particular case, we're just testing to see if you remember how to use the properties. Alrighty, number 13, 20 raised to the x power equals 54. It wants you to solve the equation. We're trying to get x by itself. Whenever you see the phrase solve the equation, we're just trying to figure out how to get x by itself. So, is that an exponential equation? Yeah. So when we have an exponential equation and we want to solve it, we got to turn it into a log equation. So I've got 20 raised to the x power equals 54. Put a dot here. Draw your circle. So log base what? 20 of equals. Now you just put this in your calculator. If you have the button, you can put this in the calculator just like it is. If you don't have the button, what do you have to put in the calculator?
Log 54.
Uh-huh.
Change the base.
Okay, so if you don't have a thick calculator that lets you put this in just like it is, you got to rewrite, type in your calculator log 54 divided by log of 20. That's called the change of base formula. What's the answer, somebody? 1.33. Number 14 wants you to evaluate. It wants you, anytime you see the word evaluate, they're going to give you some numbers to plug in. They will want you to come up with what the solution is. So, round the dollar amounts to the nearest cent and other answers to the nearest thousands when necessary. Alrighty. Okay, so, am I going to plug something into my calculator? Tell me what you're going to put into this expression. What you going to put into this expression?
Raised to the 0.02.
Okay, so we're going to put, for R, we're going to put 0.02 times 6. Now, I will put this in parentheses in my calculator where it's got 0.02 times 6. Somebody tell me what the answer is. 130 times E raised to the 0.02 times 6.
D.
Okay, $146.57. Now, this was one of the problems that we worked on in 5.5, which says that you could have money that you invested, and if it compounds continuously, you're going to use the formula with the E in it. Here's the formula, P, E, and here is the amount that you have. So it's going to be P rate times E raised to the RT power. So your principal amount of money that you had to invest was $130 times E. Do you put E in the calculator or do you put 2.71 in the calculator? E. Press the E button, raise to the percent or the interest rate that they're giving you, which is 2%. So change it to a decimal point, 0.02 times however long, and this is for usually years. So this is usually 6 years. How much money do I have in 6 years? $146.57. And that's compounding how often? When you see the E, how often is it compounding? Continuously, all day, every day, all night, 24/7. All right, question. Number 5 says find the exponential function that models the data below and use it to predict how many books will have been read in the 8th grade. Okay, so you see you got data. In the 2nd grade, they read 9 particular books. In 3rd grade, 27. In 4th grade, they read 67. 5th grade, 121. They want to know, can we predict how many books you're going to read in 8th grade? Do I need an equation?
Yes.
Yes. Where am I going to put the data? In Zuru. So if you paste your data or copy your data or type your data, in this case you'd be typing, type your data in Zuru. Where in Zuru are you going to put this data? Exponential. And it should give you an equation with an E in it. That's what it's going to give you. And you plug in what number? It's going to give you an equation with an E in it. What you going to put in the place of the X that it gives you? 8 years. I mean, not 8 years, 8th grade. The 8 means 8th grade. What equation did you get? Did somebody type it in and tell me what equation that we got?
I got y equals 2.65691065.
All right, I'm going to use that much times e to the what?
7.7354211149.
I must use that much. All righty. Times x?
Yep, times 10 to the negative 1x.
Times 10 to the negative 1. Okay, so I'm going to move my decimal over one place here. So this decimal is going to go here. All right, now what you going to put in the calculator? Replace the x with?
8.
With an 8. All right, so this has to go in the calculator. Somebody put that in the calculator and tell me what you get. Did y'all get a number closer? What's up here? You did use the exponential one, right?
Yeah. I got 6.188.
As your answer for the number books?
No, for the 0.77 times 8.
You got what again?
6.188.
For 188. For this number right here?
Yeah. Yes.
Okay. Did yours have to the negative anything too? Did it have to the negative 1 power times? No? Okay, so we need to see what that comes up to be. Anybody else get something different? Would y'all try, did you try it? Which one, what did you get?
I got there one with the 7.
With the 7?
Yeah.
Okay.
I got 6.
Okay, so I'm gonna have to type that one in, so.
I'm talking about the 6.
Yeah, I got the first one.
The 6.77354 times
Can you
8.
just do it on the screen?
Yeah, I'm gonna pull it up just to make sure. All right, y'all read them to me, hold on. All right, 0, I want exponential. All right. What were the numbers again? Somebody read them to me. 2, 9.
3 and 27.
Hold on. 3, 27. That's not 27, that's 72. All righty.
4 and 67.
4 and 67.
5 and 121.
That's it?
Yes, ma'am.
2nd, 3rd, 4th, 5th. All righty. So that's what I got. Okay, so that's, okay, so the first one we
So when
wrote.
you multiply that, it comes out to 5.75.
Okay, so when you plug in the number 8, you get what?
Oh, sorry, didn't do that. Oh,
Okay, plug in the number 8 into the equation that we got. So if we go to the web calculator and we put in, okay, it's 2.6569. Whoops, hold on. 69 times E raised to the, need parentheses, that is, we said we were gonna change that to 0.7735 4-2 times 8. All right, let's see what we got. All right.
Yeah.
Okay, so I got 1,294 books. Now, just because, what did I do with these numbers? Did I round them and chop them off? Yes, I did. So usually what you would do is take what you have in the calculator, don't truncate anything, and use the numbers that you have. So let me see, or round them up to, like if I round this up to 3, it just depends on what answer I'm looking for. I might have rounded this number up to 3. But let's see what my answer choices are. None of those, which means our actual rounding is off. So I'll go back and look. Let me look at the answer key just to see which one it is. Look at the answer key at the bottom. I just want to see which one it is. 15, that's 15. See, okay. Which is what I suspected it would be. Now, here's the question. How do you know which one we chopped off too many numbers? Do you know what I'm saying when I say I chopped off too many numbers? So when we actually went and actually pulled this, you gave me 2.6569, and there were some more numbers after that. I didn't include those. I just stopped there. Then we had some more numbers after here. We chopped it off. We didn't stop there. Now, the question is, what happens if I round this to a 3? Just curious to see what happens if I round that to a 3. I'm going to go back to my calculator again. I'm just curious now because I'm not sure how much rounding threw it off. That's a 3 equals. I'm still at 1461, which is still not enough. So I'm still not rounding up enough like I'm supposed to, or not getting enough decimal places in here. So I'll go back and take a look at that one. Let me go back and take a look at that one, guys. So if there's anything specific I need to change, I'll change it. So, but you understand the process? Yes, you just put the equation in, 0, plug in the number 8. That's the process.
Should
So,
we just leave all the decimal places in there?
yes, you should. Anytime you're doing something like this, you should leave as many decimal places as possible.
I put decimal places, still give you the same.
So,
Yeah, I
again,
did that.
you kept all of them?
Yeah.
And you still got what?
The same answer.
Okay, so let me, did we type the right information in there? All right, where am I? Yeah, I'm on Exponential. Okay, I'll take a look at that one, but the process is the same. So for testing purposes, you still put it in, and I'll make sure that it comes up like it's supposed to. All righty. Number 16, find the exponential function that models the data. What are we gonna do? Put in Zuru. Type this in and make sure this one comes up. Now, the other part that's gonna come up, remember, Zuru is gonna give you e to the something. Change the e to the something to whatever this number is. So you should get one of these numbers. This one, e to the whatever, should be rewritten as this. So just like you see what I have here as e to the 0.77, this has to be put in your calculator and it's gonna come out as one of those numbers. For some reason, my Math Lab doesn't like when you leave it as in the e format. And that could have been part of our other problems there, but hey, I'll check that one out. So type the data in for me, please. Which one did y'all get?
Y equals 20.25 E.
Okay, so we know the answer is either A or B, right?
Yes.
Okay, so now the question is e to the what? What'd you get? E to the
4.05465108 times 10 to the -1.
okay, so the decimal's gonna push this over here, so it's gonna be 0.45 and all the rest of that number. What does this come out to be?
It's 40.
405?
Yes.
Okay. 405,
465.
465, all that, put that in the calculator, it's gonna come up to one of those two numbers. E to the 0.405465 comes up to what? It's 1.5? Bless you. So, well, what's that, so we're gonna pick answer A, correct?
Yes.
So that one comes out okay. Alrighty. Questions? Number 17 says, found the amount of money in an account after 12 years if $4,100 is deposited at 6% annual interest compounded quarterly. All right, do you need a formula to work off of?
Yes.
Yes, you do. So let's see if we remember that formula. Here is, you got money. How much money did you invest? $4,100. That's your principal amount of money that you started with. So here's the formula. A equals P times 1 plus R over K. It could have an N in the place of the K, or this should be KT. Again, just know that these levels don't always have to be the same. This number, what we call K, is always going to be your compounding amount. T is always going to be your years. They could change the letters, but the process is still the same. Okay, so A is equal to, how much money did we invest?
4,100.
So P is $4,100. What's the interest rate?
6%.
6%, 0.06, divided by how many times did they compound?
Quarterly.
How many times a year is quarterly? 4 times. So the K is going to be 4. Raised to the 4 times how many years?
12.
Times 12 years. Put all of that in your calculator. Where you see parentheses, you should have parentheses. All right, question. What you get for your answer? Try to put this in your calculator. Make sure you got to be able to put this in your calculator properly. Question. Everybody got 8,378.26?
What was it? I did.
Yes. 8,378.26?
Yes.
Okay. Okay, all righty. So that's how much money we have after 12 years. Yep. Number 18, find the exponential function that satisfies the given condition. They just want you to write the function, write the equation. So how do I write this equation? What's my initial value?
55.
55, so here's this other equation. So I've got here, f of t is equal to 55. That's my initial value. What's happening?
Decreasing.
Decreasing by a rate of how much?
0.46.
What you think I should put in here? I gave you a different kind of way of writing this.
Isn't it 1 minus?
The 1 minus whatever the percent is. What's my percent?
46.
46%. Raised to the what?
T.
Okay. Is that the final answer?
No.
No. What should I do now? Go back and do what? What should I do now? Subtract 1 minus 0.46, which is how much? 0.54 raised to the t power. So that's what this came out to be. That's not one of my
Yeah, I
answers,
don't
is
see
it?
that answer.
Okay, let me see. What did we change?
Did you add 1.46?
No, because it says it's decreasing. All right. Yeah, that's got to be a subtraction sign. And my only other thought that something is off with this is if the per week is changing it. Instead of, we're doing it per year, it could be changing because of the per week. So I'm trying to think about if you do something weekly. I didn't give you all this one with where it changed, but I'm gonna assume right now, and I'll have to come back and tell you whether or not they're dividing. Remember, we have a compounding rate, and if it says per week, how often is weekly? 52 times in a year, so I'm gonna say there's a possibility that I may have to divide by 52.
Would you not do P one minus R or K?
We did, well, that's what I was trying, well, at least not 50. This is what I'm thinking, that we may have to do this R divided by K, like you just said, Robin, raised to the, and I still got my T here. So if I divide my rate by 52, what does that come out to be? Somebody tell me what 0.46 divided by 52 is. What is that? 0.46 divided by 52. What do you get?
.01095
Tell me again. 0.0.
0.8846. You want the rest of it or?
Just leave that for now, because then that has to be subtracted from 1. And subtract that from 1 and tell me what you get. Because that's another one I have to go back and look at again if it's not coming out right. And so satisfied is $50 decrease in the rate. That is, yeah.
1154.
Okay, so just leave. So that may be a possible. I'm gonna check this again. So if so, we actually had to take the 1 minus the R divided by K, which is the compounding rate. Per week was 52 weeks in a year. So let me erase this and write that. Look at the bottom of the, y'all got it up. Look at the bottom of the answer sheet. It was? Okay, all right. So let me rewrite how this should look up here. I didn't on purpose want you to do one that had a compounding rate when it was decreasing like this, when I chose that one. All right, so I've got 0.46 divided by 52 weeks in a year raised to the T power, and you said when I did this in the calculator that this comes out to 0.9954 raised to the T power. All right, so now you got that written down. All right, any question?
Yeah, where did 52 come from again?
The 52 was where they said this is happening weekly. So when something happens over a year or a weekly, it's 52 weeks in a year. Most of the ones that we did associated with the homework didn't have compounding associated with that particular formula that I gave you. Okay, number 19, it just wants you to plug the numbers in the calculator. What you're gonna put in for R? Yeah, for the rate is 0.05, which is 5%. K is 2 times a year, and then N is 7. Plug all that in the calculator. What do you get? When you looking back at the other one?
Yeah.
There's 52 weeks in a year.
Oh, okay. The T power, which one?
Say it again.
The T power.
Okay.
Which figure was saying the T power?
What happened to the T power?
Yeah, in the number 18.
What do you mean what happened to it?
No, what is the figure?
There is no number for T. It's just, see the answer key? There's the answer there. There are no numbers that you're supposed to plug in for T. Or, what is it again?
14, 12, 97.
For 19? Okay. That's just a calculator problem. So is number 20. Number 20 is another calculator. Put in the calculator. You just gotta make sure you put it in right. So it says that find the amount of money in the account after 5 years. If $2,800 is deposited at 7% compounded monthly. So I've got $2,800 times 1 plus 7%, which is 0.07, divided by how many times compounded monthly, which is 12, and then you're gonna have 12 times how many years? 5 years. In the calculator, then you should get the answer.
21 is the same too.
Okay. Okay, number 21. Felipe has a savings account with $22.38 in it. After 3 years, will the amount of interest, what will the amount of interest be at 6% compounded quarterly? Are you gonna put that one in just like we did the other ones?
Yes.
Yes. Now, do you realize you gotta do something else after you get that answer? Notice it doesn't say how much money you have. It says how much interest did you earn. So you got to take the amount that you get and subtract it from the original amount that you put in the account. And then you get how much money you actually earned in it. It's 4. Number 22. Determine whether the polynomial is cubic or quartic. Which one? It's quartic. Okay, how many peaks and valleys can it have? If it's quartic, it have either 1 or 3. Excuse me, Mr. Measure. Yeah, 1 or 3. For quartic, when I say peaks and valleys, I literally mean how many mountaintops and how many valleys do you see for this one? So if it has 1 or 3 of these max and min points, these are max and minimums. So you've got minimums and maximums. What's this maximum called right here? It has a special name. Absolute. It's the tallest one, so it's absolute. All right. So if it has 3 turning points, it's a quartic. Did I say it right? Yeah, quartic. I didn't say quintic. It's quartic. If it has 1, it could still be this. Cubic looks like this. How many turning points do cubics have? 2 or none. So for quartic, the number, I'll call these turning points. Either you have 1 or 3. Over here, for cubic functions, which are going to look like this shape, you either have 0 or 2 turning points. Quartic usually looks like a W or an M. Quartic usually looks like a W or an M. Number 23. What's the degree? The degree is your highest exponent. What's this? A degree 4, and whatever number sits to the front of that is your leading coefficient. So what's your leading coefficient? 16. So degree 4 leading coefficient is 16. Predict the behavior of number 24. It's cubic. What shape is it going to be? This one. However, because it's negative in the front, what shape is it going to look like? That. So this first one is y equals x to the third. This one is negative x to the third. So over here it opens up on the left and opens down on the right. So that one opens up on the left side and down on the right. It's B. Number 25 and 26, just want you to put them in Zuru. Where do you go put these in Zuru at? It asks for a quartic and a cubic function. Polynomial. What do you do when you get the polynomial? Change the degree to 3 if it's cubic, 4 if it's quartic. So 25, you're going to change the degree where you go to polynomial in Zuru, change the degree to 4 where it says quartic. When you do 26, change the degree to 3. Both of these fit under the button where it says PR. And 27, whoops, I skipped 27. What did 27 say do? All right, find the value of the log without using the calculator. It wants to know if you can do this without using the calculator. Here's what it's hoping that you remember. Last part, this is base 8 of 32. Can I rewrite 32? Yes, I can. So, let's see. It's going to be 8. And it's gonna be 2 times, no, that's gonna be, 2 times 16. I'm just making up all the numbers here. It's gonna be 2 times 4 times 4. All right, so those are gonna be all 2s. Does that look, 2 to the 8th power? Check it for me, please, and make sure that I do that right, because I might have written it wrong. 2 to the 8th power, nope, that's 5th. So it's not that one. 32. All right, I'm gonna use 8 and that's 4 times 8. I'm rewriting this as this function. Let me see if I got this where I want it. I just rewrote 32 as 8 times 4. And I'm gonna keep the I gotta look at how they were wanting you to do this again. That's 16 times 2, which is 32. That's base 8. I was expecting them to use base 2 instead of base 8. But it just says don't use the calculator. You won't have anything like this one that says don't use the calculator. I would expect you to use the calculator for this one, but I'm gonna look at that one as well. Because what do you get when you use it do it on the calculator? Nope. 5 divided by 3. That's fine. Yeah, let me look at that one and see why they wanted you to don't use the calculator with that one. 2 to the 5th power. Okay. All right, so your test is when? Your test is Wednesday.